Now, when it comes to object detection, the first model that comes to my mind is from the Yolo family because of its robustness and accuracy in the field of general object detection. And I actually found a very nice GitHub repo where from this AI guy's code, where I found a really nice implementation of Yolo version 4, where we can actually take the Yolo version 4 model and start detecting objects. So if we like normally when we want to detect objects from GitHub repos like this, what we can do is just go to Google Collab or any kind of notebook that we have. It can be a Jupyter notebook as well, but I prefer working with Google Collab. And here, if you can see what we do, we just clone this repo in the Google Collab. Let's just name it Yolo V4 detection test, and what we're gonna do, we're gonna connect it to an environment that is provided by Google. As you can see, it is initializing now, and yes, we are connected. So what we can do, we can clone this environment, and once we clone this environment, you see we actually have the entire repo from here. So basically what we can do, we can get into the directory, and if you want to see, we are in this directory. Oh, it was printed right here. And then what we want to do is go to the requirement.txt and see what are the dependencies that we need to run or download in order to run this run this detection. I don't want RC version, and we can just run the requirement.txt in this environment graph. It has started downloading all the dependencies. And while it is loading all the dependencies, let's just see how we can make detections. So getting started. So we are using pip, so we already are doing this step, and apart from that, we can download the weights from the Google Drive links that are here. I already have downloaded this Yolo for tiny weights from here, and if you can see, this weight is getting downloaded. So basically this is the pre-trained Yolo 4 weight files that we are gonna use to do our detection and inferencing over the images. And what it has says, so basically there are two steps for detection. So what the first step is converting the darknet weights to TensorFlow. So there is a script called save model where we pass the location of the weight file and the output where we want the converted .pb model to be saved, and the input size and the model name. And once we have saved the model in this location, we can just put this location as the main weight file location when we want to detect an object from an image, and you just pass some parameters, and here is the input directory that we want to pass. I think our dependencies are all loaded now. Yep. And what we can do now is mount our Google Drive with this Google Collab notebook. And why I am doing this is actually it becomes very easy and saves a lot of time, because I don't have to upload or download files in this Collab notebook every time if I want to use something, and I just can like pull them from the Google Drive that I want to mount. So you can mount any Google Drive that you have, added to the fact that it needs the permission. And if I refresh now, you see I have my Google Drive directly connected here, and somewhere here I have my Yolo weights as well, so I can directly access the Yolo weights that is saved in my Google Drive from this Google Collab notebook now. So now restart runtime is recommended, so I'll restart the runtime once more, and once the runtime has been restarted, I can go into the project file directory again. And once I'm in the project file directory, first I have to run the save model .py, where I just gave the path where my Yolo weights is stored in the Google Drive, and here in checkpoint Yolo v4, here somewhere our converted weights will get saved. So let's just run it and see what happens. I think it is running, as it is printing the model summary. There is a lot of parameters and layers that goes into this Yolo version 4 module, if you can see. There are 64 million parameters, quite a lot. But if we want to see how big this folder is, or the weight file is, we can just see like, not that big, but it's a like weight file that is 257 MB. It is still converting, and now the assets has been written. So basically what happened now is this .weight file, that is the darknet weights, they now have been converted into a TensorFlow version of .pb model, and we will be using this .pb model in order to do our inferencing. And now if we want to run detect.py, so what I do, I just provide checkpoints Yolo v4 for 116 here as the input path of the weights, and if you want, I think there will be some images here as well. Let's see data sets, not the data sets but images, and here we can see there is an image of a dog and a bicycle. This is a very popular and common image used by Yolo. So yeah, let's just do some inference in here. We just copy the path and replace the path here. And let's just run the detection now. I guess it's running. And it has completed this detect.py, and if you can see the total number of objects is 3. And now if we go to detections and detection 1.png, we can see the dog, the bicycle, the truck. The total number of objects, that is 3. This has been detected from this input image. So yeah, nice model that we have, which we can use to do inferencing. But now how can we implement this into a web service? And this is what we are gonna see now in the next part of the video.